Hello. Welcome to the Introduction to Editor Programming talk. My name's Tim Cooper. I'm an editor developer at Unity Technologies. Before that, I worked at 2K Australia, and I've worked on titles like the Bioshock series and the soon-to-be-released XCOM. And this is my colleague, Sean.
Hey, I'm Sean. I'm also an editor developer at Unity Technologies. Been there for a little over a year. I'm more from an indie background, but that doesn't prevent us from being friends. And yeah, so let's get started. So today we're going to talk a little bit about editor scripting, and let's go over how we will do custom GUI inside of the editor. So this is the editor the first time you load it up, and in this specific layout we have 4 editor windows. We have the scene view, we have the hierarchy, we have the project view, and we have the inspector. The inspector is very special, and Tim will tell you about it.
Yes. So the inspector is a special window that we have in Unity. And what it does is, for every component you have on one of your game objects, it displays a specific editor tailored to that behavior. As you can see in this example, the 2 behaviors we have at the top, which are a camera and the transform, have a custom-coded editor. They're not displayed using the built-in Unity default inspector, whereas the 2 at the bottom have basically the built-in, which is what it happens if you do not provide your own custom inspector script. Both have advantages and disadvantages, which we'll be talking about later, but we're going to move on and come back to that. So there's 2 kinds of custom GUIs you would normally write or use with Unity. They are editor windows, and editor windows are normally used for tools or big plugins, specifically things like the visual scripting languages that exist on the asset store or the shader editors, whereas inspector editors are very specific, and they're used for editing mono behaviors and things in the scene and at a smaller scale. So the first thing we're going to quickly cover is we're going to give an overview of a simple inspector editor. So hypothetically, say you have a class called the soldier controller class. This has a speed associated with it, and we wish to write a custom inspector so you can see this speed as you have here, like you can see on the bottom. Now, the first thing you have to do if you have one of these scripts is you have to define a custom editor and give it the type that you wish to inspect. So in this case, at the top you can see we have custom editor, and we pass in the soldier controller class, and it also has to extend from the editor. This allows you to basically plug in, it enables the on-inspector GUI callbacks and all the nice things you get in an inspector for free. The next thing we do is we define a serialized object and a serialized property. A lot of the time you may use targets, but we're going to cover serialized properties and objects here because they are a better way to do things. A serialized object is created by passing in the target, and then from that object you pull out the property which you're interested in inspecting, in this case the speed property. It's just the name of the parameter as it exists in the mono behavior, and it's pulled out using some funky reflection internally. The next step is, that's in the onEnable block, and the onEnable block is called whenever an inspector is loaded or you switch between inspectors. So the onInspector GUI callback is used for when the onInspector GUI is rendered. If you've ever made an actual game in Unity and use onGUI, this is a similar callback, except it's just used for the small inspector window instead of for a full screen, which you render into normally. If you're using serialized properties, the first thing you want to do in your onInspector GUI is call update. What this does is it pulls the relative variables from the Unity runtime and stores them in the object, and then you can, when you've finished modifying them, you push them back using the apply modified properties. If you're using serialized properties, you get a really nice feature, which means you can just pass through to a property field the property, and it will automatically place the correct field type. So in this case, the speed is a float. So as you can see, it's used a float field. This works for all different types. So if you have an int or a vector3 and you use a property field, it will automatically display the correct type straight away.
But Tim, why no editor target?
Well, that's an interesting question, Sean. And there's quite a few advantages you get from using serialized objects and serialized properties that you don't get from using the target. As you saw earlier, we created our serialized object using the target, but it's not the best way to modify the object. By modifying the target, you modify one target directly in memory. By using serialized objects and serialized properties, it allows you to have prefab styling. That is when you say override a few properties in a prefab, and it displays them as bold so you can see that they've been changed. It allows you to revert individual values on a prefab by right-clicking. It also implicitly supports undo and redo, and it also has, as I mentioned earlier, the controls for all the common data types. And in Unity 3.5, by using serialized properties, it will implicitly support multi-object editing, which using a target will not do. So I'll pass you over to Sean.
Cool. And then, like Tim said, the other place that we can often have custom GUI is inside of editor windows. So, and also, as he said, editor windows are more common for tools and modifying a bunch of objects in a scene, or modifying a bunch of assets or something like that. So here's a very, very simple bare-bone editor windows class. And this class actually, all it does is create a window that pops up, and it has absolutely nothing in it. So let's go through it. First, we have the editor window class that you inherit from, and with this class, and this gives us all the API we need to use the class. And there's no like attribute that you would have to have for an editor window. Next, we have this menu item, and the menu item is the most common way to create an editor window. It's how we do it for most of the editor windows inside of Unity right now. So with the menu item, you pass it a string that determines where it's going to show up inside the menu. Once it's clicked, it calls the static method that's immediately below it. And this static method is where we actually create the window. And we use getWindow, which is a nice little API that we have, which allows you to, it will find the window if it currently exists. If it doesn't exist, it'll create it and pop it up. And then we have the onGUI callback. And just like before, this is the callback that we use to draw all of our GUI and do all of our onGUI controls. And that's pretty much it for an editor window. It's much simpler. And I got lucky to not have to talk about inspector editors. But I get to talk to you about the demo. So let me switch this over. I have to do some magic to make this thing work. Oh God, what am I doing? I'm almost there. System preferences. Good, good, good. Arrangement. Success. Okay, uh-oh. There we go. Okay, so here's the scene, and we get this in the correct view selected. There we go. Now we can actually see what's happening. So we have this dude here, and this dude has the soldier controller script that we were using before. And let me actually go in here and do some of this so I can show you guys exactly what it looked like before. No. So let's click this guy. So this is what the generic inspector would look like for this guy. So we have a speed and a whole bunch of waypoints for him. If I hit play, he'll run around kind of goofily to all these different waypoints that he's currently trying to go to. And we can change the speed, make him go really slow, and stop him. And you can go negative, which doesn't really make much sense in this case, and actually kind of breaks it, and which is kind of a limitation of the generic editor. And with these waypoints, I can go in here and I can change the size of it, and it duplicates the last one, which makes no sense. And then we have to, there's no way to reorder them or anything like that. So we're going to create a custom editor for this to do things like that. So let's stop this and then hop into here. We have these pre-made. Copy that. Expand this so you can actually see. Can everybody read that? Probably not. Can everybody read that, or anybody cannot read that? Okay, I'll see what I can do. Zoom. Okay.
Zoom out a tad.
Okay, zoom out just a little bit. All right, so here's a little editor script. And this looks very similar to the one that we had in the slides. We just have a little header here that's in there as well. But like we said before, we have these serialized object and serialized property fields. We initialize them in onEnable, and then we pull the data from the object from the runtime, and then push it back to the runtime after it's modified by the property field. Nothing too fancy. So we zoom out here, go into Unity 3.4, let it reload. Now we have this speed thing. Click play. It works just like before. I can move it back and forth. It goes below 0 still, but we can fix that. That's what we'll fix next. One of the quick things we can show off. So we copy this, go back into MonoDevelop, paste. So you notice it looks almost exactly the same, except that we have this additional thing right underneath the property field. So the property field is modifying the speed serialized property, and then we can get the float value of the speed serialized property, check if it's less than 0. If it is, we'll just set it to 0. And this is a really simple way to just clamp it to make sure it's above 0 at all times. So now if we go back to Unity, did I save that?
Yep.
I did. Hit play, and now you notice I can't go less than 0. Pretty fancy stuff. Pretty awesome stuff, at least. So now we need to handle some waypoint stuff. And this is where it'll get a little bit not so trivial. So if I copy all this into MonoDevelop, notice that it just got a lot longer. But it's not that bad, and I can walk you through it. So if you look on the onInspector GUI here, If you look through the onInspector GUI here, notice that this is all the same. All we added was this little section down here. The first part is just another header. And here, we get the waypoint array. And I'll go into how we're getting that in a second. But we're just getting it. This is an array of waypoints. We loop over the array. We create an object field for each one of these. And if the object field is changed, we set the waypoint. And this get waypoint array is getting it from the serialized array property. And the set waypoint array is setting the serialized array property. And then we can go up to here to get a waypoint array and actually see what's actually happening here. So if I zoom up a bit, oh god, this is really weird to work with. OK, so we have this get waypoint array thing. So we have array count. We're going to get the array count from the serialized property. So we have this paradigm for serialized properties where the first one is the waypoints, which is the field that's on the soldier controller. So if we look at the soldier controller, there's a field here called waypoints. And that's what determines this string and serialized property. Then the array just means that we're expecting an array, and then we get the size of that. And this is the path to the serialized property. And then we can pass that directly into the find property for the serialized object. And that'll return the int value of how big the array is. Then we can get the int value of that and just store that into the array count. So we do that. We create a new waypoint array of size the array count. Then we loop over all of it, or we loop for that array count amount. And for each one, we do a find property to get the object reference there. So if you look up here, we have another path for serialized property. And this is how do you get the data for all the for the array. And this is just the path to it. And then we'll replace this little token here with the index. You can see that there's a string format down here. And that's just replacing the current index in this token. And then we find the property on the serialized object. We get the reference value. It's a waypoint. Save it as a waypoint directly into the array. And then we return that. That is how we would get the serialized property array from the runtime. And then we just iterate over it, create the object fields. And then the set waypoint array is, or set waypoint is very similar. We find the property, serialized property, using the exact same array data of whatever index we passed in. And then we set the object reference value directly. And that's much more simpler than it may have looked right at the beginning. But the nice thing about this is it handles undo and redo nicely, and it'll handle all the other nice things that we get from serialized properties. So we can zoom out here, save this, hop in here. And now you notice that we have an array of object fields in the lower right-hand corner. And I can play, and I can go in here and take one of these waypoints and replace waypoint ASDF, and he'll move to that new waypoint now. Cool. But we still haven't duplicated the functionality of the generic inspector yet. So we go in here, copy this bad boy, go in here, paste. And now we can have, we have a button for adding a waypoint. So it's just a simple GUI layout.button for add waypoint. It's going to be added after all the array of object fields. And what we do is we just get the waypoint count. It's been abstracted out into a serialized field, serialized property field. And we just increment it. That's all we do. And it's just like modifying a generic array inside the inspector. Whenever you increment it, it duplicates the last one afterwards. And it's the exact same behavior. So all we do is increment the int value. The array is one larger. And then we can just set the waypoint on at that index to null. So if I save this, go in here, and I can just add waypoints magically. And then I can drag these in as I want. And now we have a dude that goes to, what, 6 different waypoints? Cool. And then to finalize to finish duplicating functionality, we can remove waypoints from this array. So let's go in here, grab this. Cool. And now we added one more button right here. It's immediately after the object field. So we added a begin horizontal, end horizontal to make it so it happens in the same horizontal grouping as the object field. So there's a button afterwards of a constant width of 20. And then we have this new remove waypoint at index. And it does a similar thing. It calls set waypoint. It iterates over the array, starting at the index that we want to set, and basically gets the waypoint of the next index and replaces the current index, and then does that for all the following indices. And then at the end, it just decrements the array count. So if we do that, go in here to Unity. Now we have little buttons after here, and I can just kill waypoint ASDF, and now it's gone. I can just keep on killing them. So now we have duplicated the functionality of the old one.
It's even better because you can do it any waypoint.
Yeah. Cool. So let's add some functionality here. Let's go in here, copy this guy, go in here. OK, so now we have 2 more buttons, a U and a D for up and down. And now we're modifying some GUI.enabled in here. So GUI.enabled gets set to true or false based on whether the waypoint can be moved up in the array or not. And basically, the reason it may not be able to move up in the array is if it's already at the top. If it's already at index 0, you can't move it up for any further, right? Same for down. If it's already at the maximum index count, then you can't pull it down any further. And if you look up here, it's that simple. If index is greater than or equal to 1, then it can move up, and then the same for down. So then that's how we set the GUI enabled. You might notice that we have an old enabled, and we're actually setting this here. And the reason we do that is we actually want to make sure that you keep the old enabled flag if it's already set to false. Obviously, we're not setting it to false anywhere in here, but it is possible that it can be set to false at some time, especially when 3.5 comes out. And with version control integration, there are certain version control things like perforce or subversion that can actually lock assets. So if the asset is locked, it's going to disable all the editors for it. And we don't want to override that disable. So we need to make sure that we maintain that enabled state. And here we just swap waypoints. And this is just a simple swap algorithm. Save a temporary waypoint, set the waypoint, and then set the next waypoint with the temporary waypoint. So if I save this guy, go in here. Now we have these up and downs. So if you see waypoint ASDF, I hit up, he goes up and down. So now we have additional functionality that we didn't have before, which is pretty awesome. Cool. So I'm going to pass this off to Tim to continue.
Yep. So the add functionality is quite interesting, but it's not the best. So we actually want to be able to drag waypoints from the scene and just drop them, and it'll just add them straight to the end in one go without having to click add and then do a drag. So what we're going to do is we're going to do this, and I'll just quickly show you how it works before we go through the code for this. So there's now this add waypoint box at the bottom, and any waypoint you drag in here, or selection of waypoints, will just be added to the end of the list. So hang on, I'll just grab the character, and let's drag a waypoint here, and as you can see, it turns into a plus, and then when you let go, a new waypoint is added. Now, drag and drop is one of the more interesting event handlers in Unity, so we're going to cover it here. So if you have a quick look at the on GUI, it's exactly the same as before, except now at the very bottom we have drop area GUI. And this is where we implement all our drag and drop code. So the first thing we do is we cache the current event. I might just zoom in a bit, sorry. The first thing we do is we cache the current event. And then we just get a rectangle which has a width as wide as the inspector and a height of 50. This is achieved by setting a height of 50 in the requested get rectangle and expand width to true. We then draw a box called drop area, which as you saw was the box on the screen where you could drag and drop. The interesting part now is in the drag performed and drag updated. With Unity, whenever you are dragging something around, the event drag updated is sent to any GUI controls that you are dragging over. When you finally let go over those controls, a drag perform is given. So the first thing we do, and we do this for both drag updated and drag performed, is we check if the create a drop area contains the mouse position. If it doesn't contain the mouse position, we just break because we do not want to handle this event on this piece of GUI. If we are over that position, we then set the visual mode to copy, which is why you saw the plus appear when we moved the drag and drop icon over the top. Setting the visual mode enables drag and drop for this control. If you don't set the visual mode, it just won't work. So what we do then is if the event is instead drag perform instead of drag updated, drag is performed, drag perform is sent to the control when you mouse up. We then call drag and drop except drag, which registers that this drag event has been handled by your controller. We iterate through each of the objects in the drag and drop object references. We check that it's a game object and we check that it's a waypoint. And if it is, we just call add waypoint as you saw earlier. The final thing we do is if we haven't broken out of this statement is we just use the event. So no other controls will use this event later because it's our control we wish to use. So as you can see, I'll just drag and drop one more for you. So I'll just add ASDF again to the end, and it just appears like so. So the next thing we're going to cover after drag and drop is, what do we have here, is on-scene GUI. So we're starting to look at things now that we wish to show the state of this object in the scene rather than just in the inspector. And via custom inspectors, you can actually draw helper lions or anything like that in the scene as an overlay. So what we're going to do now is, if I jump back to here and put that in, is on our character, you see this white line coming out of his feet. This is a representation of the direction the character is facing and the speed in which the character is moving. So if I modify the speed here, you'll see the line get smaller and larger. So you can potentially use this if you write some artificial intelligence or something to show the heading of your characters, what kind of goals they're following, and lots of little things like that. So if we play this, you'll see the waypoint, the line, just it's in game view. You'll see that the character follows that line and it points to the direction they're facing. Okay. The way you do this is actually quite simple. We have a new function now called onScene GUI. OnScene GUI is called for, in 3.4, any selected mono behavior that exists in the inspector. And for this, we basically we use the target now, not a serialized property, because using serialized property in this context doesn't make so much sense. So the first thing we do is we cast the target to a soldier controller, and then we get the current position of the transform of the soldier, and then we just draw an arrow using draw arrow cap here. We start drawing the arrow at the current position. We rotate the arrow based on the soldier's rotation, and then we just draw an arbitrary sized arrow based off the speed you've set and times 0.3, because that was just a magic value that looked nice for us. Okay, and the second last thing we're going to show is, so you've added all these waypoints, but there's nothing in the scene to see the order of the waypoints and how the character is going to move between them. So the next thing we need is we're going to add some on-screen GUI to show drawing between waypoints, so you can see how the character would move in the scene. So we'll just add this here. So the first thing we do is we use the handles class to do this. So we preserve the old color and we restore the old color at the end, as you can see. This is basic housekeeping, just like setting the enabled state. You want to leave things when you return in the same state that you started in. So that's one of the things we always do at Unity. We try and housekeep inside these functions. So the first thing, we just iterate through the waypoints. And then for each of the waypoints, we draw a line, which is just the line between the handles, the line between the current waypoint and the next waypoint. At the very end, we draw one more line, which is from the last waypoint to the first waypoint. And it's as simple as that. So let's jump back to the demo. And now you can see that there is a triangle that has appeared here, which is the waypoints. So this is not the best setup. So I'll add another waypoint here and see if we can't see a bit more. Ah, there we go. So now you can see that the player, he'll run between them. And if we go to the scene view, you'll see that he basically follows those. So we've got some duplicate waypoints in the middle somewhere. So if I maybe delete that one. Oh well. OK, and the last thing we want to do is we want to see the order of the waypoints, not just the lines between them. So what we do is as simple as this. We, in the GUI block, as we're drawing, we draw the lines, the waypoints as they were before, the lines. Then we do a begin GUI block. This allows you to draw any kind of GUI in the scene. So just like you would normally in the inspector draw a GUI or in a game GUI, you can draw things on top. What we do is we iterate through the waypoints, and using the handles utility, we use world point to GUI point. This translates any arbitrary vector3 position in world space into a position on the screen. So we offset that a little bit to get a nice rectangle, and then we just give it the name and the position in the waypoints array. So quite simply, we can see above each one the waypoint number now. So yeah, so there we are. And I think that brings us to the end of the inspector demo. And I'm going to pass over to Sean again now.
Cool. So like we said before, there's two different places you can have custom GUI. That's in inspector editors and editor windows. So let's take a quick look at editor windows too. So let me go in here, find this other guy. There we go. So we have awesome editor window here. And this is very similar to the one we had in the slide as well. And this just creates an empty editor window. So if I hop into here and go into awesome stuff, awesome window, this is what the menu item created for me. I click, and it creates the window for me. Obviously, it's not very useful at the moment, but it's not too bad. So yeah, we have the window now. Let's go in here and make some awesome stuff for it. So we decided that we wanted to basically make Photoshop inside of Unity. We have the technologies, why not? We have the power. So let me show you what we did here. It's kind of hard to see on the projector, but
it'll get better.
Cool. Yeah, it'll get a lot better in the next one. So basically we have a canvas of pixels that are different colors, different random colors. And if we take a look at the script here, we have two callbacks, on enable and on GUI. On enable is called anytime the editor is created, or the editor window is created. And in this, we have a width and a height of the canvas and an array of pixels. Width and height we just set to 8, and we initialize the array of pixels to 64. And then we iterate over all the pixels and just set some random color to it. And down here in on GUI, we store the state of the old color, and then we'll restore it at the end. And then we lay out all the pixels using begin horizontal and begin vertical. And then we have in the middle of that a GUI layout box, which just expands height and expands width, means it takes up as much space as it can. And we just set the color of that box, which is why it's not very visible at the moment. So if I go in here, select this one.
That's 3.
Yes.
Yep. That's correct.
We did a couple things here. First, we replaced the GUI layout box with a GUI Draw Texture, which just makes it a white texture multiplied by the GUI.color, which will make it much more visible. If we take a look at it in here, oops, I didn't save. There we go. Now that should be much more easier to see, much more easier.
Much easier.
Yes, yes. My grammar is not that great right now. Kind of jet lagged. So one of the things we added here is getRect. And getRect is a nice GUI layout utility thing that will reserve a rect in the GUI layout system. So if you want to just get a rect from the GUI layout system and just handle drawing inside the rect and everything else is inside that rect yourself, but you just want GUI layout to reserve that rect and not have anything else interfere with you there, you can just use getRect. And then you can pass in content or a style, and it'll figure out what the best rect for you is. In this instance, we don't have any content or style. We just want to make sure that the rect is expanding the width and expanding height, just like we have for the box. And we get the pixel rect, and then we draw the texture with that pixel rect. The other thing that we're doing here is listening for the mouse down event. So if I zoom in here so people can see. We listen for the mouse down event. And we also check to make sure that it's within this pixel. And if it is, then we'll just set that pixel to some other random color. So this is, you can see where this is heading with mouse events for setting the pixels. So we go back in here. You can see if I click on these, it'll change colors. So I'm going to give this back over to Tim.
Yep. What are you doing now? OK, so after we've got the simple ability now to set pixels, but we want to set them to specific colors. So in the onGUI, we've now divided it into two sections. There's the do controls, and there's the do canvas. What we've done with this is we've broken it into a horizontal block. So the controls will be on the left-hand side of the horizontal block, and the canvas will be on the right. The do canvas is quite similar to what it was before. The only difference, I'll cover the differences in a little bit. The main differences are in do controls. So what we do is we're in a sort of a horizontal space section to the left now. Should actually copy this across so you get some syntax highlighting. OK. So the do controls are in a vertical block that's aligned on the left-hand side. And so the first thing we do is we draw a toolbar, or we draw a label saying toolbar. The next thing we do is we have two color fields, and color fields an inbuilt Unity type, and we have a paint color and an erase color. What we're going to do with these is we're going to use the paint color on left click and the erase color on right click. We also add a button called fill all, and what that does is it just iterates all the pixels and sets their color to the fill color, the foreground color. So now we can set the select and erase color. Instead of using a random color, on mouse down, we check what button was pressed. And if it was the left mouse button, we set the selected color, whereas if it was any other mouse button, we use the erase color. So I'll just show that quickly. So you can see here on the left, we have a toolbar, and we can set a color, and then you can just paint onto this canvas that color. And you can also use the fill all, or if you right click, you can do an erase. So there we have it. Was there anything I missed in there? No. So that's how you create a simple pixel painter. The next part of this, which is more interesting, is so we've created a tool to paint, but how do we actually use these textures or these little pixel grids we've created? So what we've done is to show just what you can do with editor extensions. We've made this a tool which you can export textures into the scene and have anything in the scene be painted with these textures that you like. So what we do is in the controls now, we have added an extra button called Save to Object. Now what this does is if you have an object, you can select an object in the scene, and then once you click Save to Object, it'll push these pixels into a texture and set them as the material. So I'll give you a quick demo, then I'll explain how it works. So let's just let this reset. OK, and I'll dock this. Hang on. Move that, Sean. Just there. I'll dock this just here because it makes it a little bit easier to see what we're doing. Kill the inspector, yeah. That's OK. So as you can see, there's an output renderer field added just here. So what we do is we're going to just create simply a new cube. I'll just move that up a little bit so it's visible. Focus. So what we can do is we can drag this cube into here, and when you click Save to Object, it'll set that as the texture on the object. So one thing you can do is, quite quickly, we'll just do this. Start with a brown color. We'll fill, and then we'll just create some green on top. So, and what we're doing is we're just going to create a little block, and then we're going to save it to the object. And so you can pretty much like create little Minecraft cubes. You can't really see the color on that because the projector's a bit dark, unfortunately. But that's a little Minecraft cube. Yeah, Minecraft. So if you were making a game similar to Minecraft or something, you could write an editor extension like that, so you can paint your own blocks and then just export them into the scene as you feel like. The way it works is actually quite simple. It's just using everything's all inbuilt Unity things. What you do is there's an object field that we've created, as you saw, the output renderer, and this is just an object field. It just selects accepts a scene renderer. And then if there's one that's valid, the GUI will only be enabled if that object is invalid. The GUI will only be enabled if there's an object set. If there's no object set, the GUI will be disabled, so you can't actually click the Save to Object button. But if it is valid, the first thing we do is we just create a new texture 2D with the width and the height. We set the filter mode to point, just so it looks like nice and blocky, instead of having a really blurred out bilinear filter on an 8x8 texture. We then just create a new material for it, like so, and we set the texture. And then the last thing we do is we set up the actual pixels on the texture using set pixels, and then we apply, and that creates the texture for us and sets it. So I think the last thing we're going to cover is, I'll just bring this up like so. Can I play at that stage? Yeah, is Unity 3.5. There's a few changes going into the Unity editor in 3.5, which you should probably be aware of if you're making custom editors and custom inspectors. The first thing is multi-object editing. I've been using it for a while now, and it's seriously very, very handy and very cool. And
it's the best feature in Unity 3.5,
yeah.
Hands down.
If you're using like a lot of scene editing, it's amazing.
All that stuff in the keynote, no. It's the best feature in Unity 3.5.
So the first thing that happens is you saw that there's a target field. In Unity 3.5, we've also added another one called targets. Target still exists, and it just points to the first target in the targets array, so we don't break any backwards compatibility there. But by using targets, it allows you to basically, you can do multiple objects at once if you just still decide to use the targets instead of a serialized property. The next thing you need to do is, if you have an inspector, is add the can edit multiple objects attribute to the top of your class. Normally we just add it above the custom inspector attribute. This enables multiple editing on your inspector. There's also a field added to an editor, which is the serialized object. In the examples you saw today, we actually created the serialized object using the target. That's now implicitly provided for you via serialized object, so you don't have to do it. Also, on-scene GUI is now called for all targets rather than just the first one you have selected. And it's basically called once for each target in the target array. And we've also added, you might have noticed that the array handling was quite cumbersome for serialized properties. We've actually added a much nicer serialized property handling for arrays. So there's now an isArray attribute and a delete array item at and a set array item at. So it's a lot simpler than what you saw there. But yeah, thank you.
Does that include push and pop?
No. So are there any questions?
Yes.
I think you were first. I'll come back to you.
Real quick, please tell me you have an URL in that code.
Not honest, but we can make it so.
Repeat question.
Yeah. Do we have a URL for that code? We can get a zip file of that and put it somewhere, right, Sean?
Yes, I say that after every single talk I give, and then I forget to. So if you guys, you see my Twitter there?
Yeah, see the Twitter
bombard
addresses.
us
Just
with
keep
requests.
posting us
And then
on
we'll get
Twitter
annoyed,
until we
and
do
then
it.
we'll finally do it. So.
Yeah. Yes.
Within the Unity editor context, can an editor plugin access another editor plugin's variables or get introspection on their state?
Hey guys, could you keep it down while you're getting up? This room is terrible acoustics, so keep it quiet, please.
Yeah.
So can I have an editor plugin that can tell me what's happening in the built-in Unity inspectors, for example, or another editor plugin?
What do you mean by tell you what's happening?
For example, okay, so like we made Code Hero, it's a video game that teaches you how to use Unity, right? So could we make part of Code Hero an editor plugin so that while you're using Unity, it can tell you what to click on and how to do things in Unity?
So the question is it possible to have an editor window or some editor know about basically the state of other editors and other editor windows? And the answer is yes. Through the magic of reflection, you can basically do everything. But it's going to be basically one great big hack. And it's going to break basically anytime we make any changes to one of the editors.
Okay.
But yeah.
Who should I talk to about that kind of epic hackery on the system?
Go up to whenever in the hands-on session, probably somebody on the scripting side, somebody that's like a mono guru. Levi, Rodrigo, myself, and pretty much anybody else on the editor team can answer your question on that.
I think you just volunteer.
Yeah, but not now.
Yep. Are there any other questions? Yes.
Is this just a C# thing, or is it also available in JavaScript?
Oh, it's totally available in JavaScript.
Yeah.
And Boo.
Yes.
Where's the best place to find documentation on the new features? Is it going to be in the manual? Or
Yeah, all these, there's examples in the scripting reference about how to use editor windows and editor inspectors and all that kind of thing. They're just not as, they're not so much tutorially rather than a reference. So.
And all the new features will be documented and everything, so it's all good. Yes? What do you mean by dynamic text?
Apps that, for instance, run on mobile devices that more engineers would. I had a search field that was right here, and I changed it to other content. There was a huge drop in application.
Yeah, I mean, I'm not. So the question is,
Is there any performance increases on the GUI?
yeah, are there any performance increases on the GUI for 3.5? And the answer is, as far as GUI layout goes, and just this editor GUI dot box, GUI dot label, the basic answer is no. But that's because all the runtime stuff, we want you to use the new GUI system. But we didn't really talk about the new GUI system in the keynote. But there will be a new GUI system at some point, and it's what you really want to use for runtime, especially for iOS and things like that. Mm-hmm. Yes, Matthew.
I have a question about editors that you want to ship to the player. Like if you wanted to expose your Minecraft texture editor, what's the best practices to make that also shippable and not just stuck in the editor?
So the question is, what's the best practice to make an editor window shippable to the player, or to so you mean to a player or to another Unity user? To a player.
It's not using editor extensions.
Yeah, you're no longer using editor extensions. You have to write on GUI stuff, and basically you're creating runtime on GUI at that point.
I think you were next.
Say that one more time. I'm not.
Can we change the default, or can you change the default array handler for serialized property rather than?
Well, you obviously understand the question, so.
The question was, can you change the default, basically components from serialized property, instead of having to write your own custom ones, just override it on a project-wide basis, I guess? And the answer to that is no, not currently. We've never really thought about it, actually. So maybe we should Yeah. So, sorry if that is not the best answer, but you can't do it currently. Yeah. Yes.
In order to sort your array there, you had up and down buttons. Would something like a drag be possible in that? So where you could just drag the array on one, I want this one to be number one from the second to last.
Yes, that's.
So the question is, would it be possible to drag the waypoints around instead of clicking buttons? And the answer is yes, totally. We had thought about doing that initially for the project, but then thought it was going to be a little bit too complex to actually go into in a talk. But yes, it's totally possible. I mean, if you also in actually this came out in 3.4. There's the script execution order window editor, and that's just using click and drag to reorder things, and that's just the exact same thing.
So basically, you'd be using drag and drop handling for all of this stuff. Yep. One.
On the same note about exposing editor stuff, so part of the editor plugin is Unity GUI stuff, right? So the other part is like the handles and the things that are editor context specific. So the question is, could you write essentially a substitute for the editor only stuff that would run in runtime, and then you could reuse an editor in both contexts?
I guess you could using. Repeat the question. The question was, could you basically write your own handles and windowing code so you could reuse them between both the runtime and the editor? And the answer to that is yes, but I'm guessing it would be quite a large task, and you'd have to manually handle proxying, whether you're in the editor or in the runtime yourself. Yeah, it'd be possible but difficult, or time-consuming at least. Yeah. Yes?
Is audio data exposed to the editor windows? For instance, could you take an audio file and show the spectrum of it like you would in a sound editing program?
So the question is audio data exposed to the editor window files? And the answer is yes, but I don't know if that API is marked as internal or not.
So yes, but not for you.
Yeah, it may not be. There's a lot of changes going into the audio API for 3.5, and that also includes editor-only stuff. And even if it is internal, it is possible to access it via reflection. Reflection magic. You can actually call basically any internal function using reflection. Just that's not supported, by the way. And if you do it, you're running your own risks there. But yeah.
I think you just answered my question. What's the policy on using reflection?
You can do it, but it's going to break at some point. I guarantee you.
Yes?
Is there plans to kind of roll in what you did in your inspector example to the default rendering of the editor? So like when you do arrays of things, you could move them around and you could delete them and stuff like that.
You can already delete with control backspace.
Yeah. So the question is, are there plans to actually have nicer array handling in the generic editor? And there have been talks internally, and it's actually a little more complicated question because it's a lot of it's context based. But it's but yeah, in a very generic way, you should be able to easily delete and add at index or move things around. But there's actually some pro tips there. If you select one of them and hit Command D, you can duplicate it at that index. And then if you select one, you can delete at that index. And unfortunately, you can't move around right now, which is kind of a pain. And that's just, it really is a matter of just we need to sit down and do it. But yeah.
So for the serialized objects, let's say you have an entire army of guys that want to change their speed. What's the memory footprint of getting all the targets all at once?
So the question is, so this is like a 3.5 thing, right? Yeah, so the question is in 3.5 when you have multi-object editing and you select a whole bunch of objects and you want to modify all the values on these objects, what's the overhead of actually selecting all these objects? And the overhead it's there, but it's actually not that bad. I mean
it's very small actually. We don't actually return all the values. We just return if they are different. So there's no memory footprint in that regard. The UI either knows if they're different or if they're the same.
So if you're modifying assets in the scene, it's very, very little. if you're modifying assets in the project, we actually have to load all those assets to check. So that's actually can be a bit slow. If you select 50 textures or 50 audio clips, it may take a second to actually load all those up because you actually have to actually load those into memory to test them. So, more questions?
Just a quick question. Inspector windows stay saved, scene is saved, but editor windows stay what's in the window once. There's no way to save it unless you do a script for it. I mean, if you save the inspector window, you save the scene. Everything you said, the inspector window is saved.
Yes.
But the editor window is not.
That is correct. So the question is, in an inspector editor, all the serialized data is already saved. It's saved into the scene. And with an editor window, it's not as obvious on how to save this data. It is totally possible. I mean, you just need to serialize the data yourself and put it somewhere. You can create an XML file to save the data into. You can use editor prefs, which is one common way to do it. It's just there's an editor prefs class, and you just save an int or a string or whatever, and serialize. You can serialize that all your data into a string, save it, and then deserialize it out on enable and on disable. I mean, it's just we don't have a generic way of handling that right now, and we may have one in the future, but it's totally a solvable problem serializing the data yourself. Any more questions? Hide behind this poll. Nope.
Okay. Thank you.
Cool.